Okay, so the way that we're going to show for if IVT works or doesn't work is we're going to verify using the two conditions. So from the front, hopefully you realize that f of x has to be continuous for IVT to work. So the first thing that we're going to check for is f of x must be continuous. And it has to be continuous on our interval from a to b. That means it has to be continuous on the endpoints as well for a and b. And then the other part that we're going to check for, f of c, so that's that y value, must be between the y value of a and b, so it must be between f of a and f of b. So questions that we're going to see, like in example 2, they're going to say, determine if IVT is applicable, so that means does it work? And then if it is applicable, we can actually figure out the value of c. If it's not applicable, you can't figure it out. So first one, we have this rational function here, and we're on the interval from -1 to 3, and we're trying to see if f of c equals 2/3. So the first thing that you have to check for IVT is that it is continuous. Well, think about what a rational function looks like. It can have holes and it can have vertical asymptotes, which would make it not be continuous. So there's no holes because there's nothing to cross out. But you would have a vertical asymptote at x equals -2. Okay, because that's left in the denominator. So at x equals -2, it's not continuous. But you only care about your interval that they give you here. So is -2 between -1 and 3? No, it's not. So we got to write this all out. So we're going to say f of x is continuous on our interval from -1 to 3. Now you do have to make mention of that vertical asymptote that you know you've checked it. So we're just going to say f of x is only discontinuous at x equals -2, which is not in the interval. So even if it is continuous, you have to give some kind of reason. So you know that it's discontinuous at x equals -2, but that doesn't matter because it's not in our interval. So step 1 works. Okay, then the second thing you have to check for is f of c has to be between f of a and f of b. So to do this, you're going to plug in. We're going to do f of your lower endpoint, which is -1. And we're going to plug in -1 to our little equation here. So we get -4. And then you're going to do f of your upper endpoint, which is 3, so f of 3, and we're going to plug that in. And that's going to give us 0. So we have to check, is 2/3, because that's the y value that we're looking for here, is 2/3 between -4 and 0? No, it's not. So we're going to write f of c equals 2/3 is not between f of -1 and f of 3. Okay, 2/3 is the y value. It's not between -4 and 0, so it's not between our f of -1 and f of 3. So 2 does not work. Well, remember, if it doesn't work, that means that you stop, which that was the only second step. And now we're just going to make a statement. So the IVT, intermediate value theorem, is not applicable. All that means is you can't apply it for f of c equals 2/3 on the interval from -1 to 3. Okay, so if we look at problem B here, we have the same rational function, but we have a different interval here. Okay, so we still know that we have a vertical asymptote at x equals -2, but we're on the interval from -4 to 1. So when we're talking about continuous, is -2 between -4 and 1? Yes, it is. So we would say here f of x is not continuous on our interval from -4 to 1. And we would have to give a reason. We would say because there is a vertical asymptote at x equals -2. Well, number 1 didn't work, so we stop. We don't even have to check number 2, and we just make a statement. So we would say, therefore, the IVT is not applicable for f of c equals 2/3, which we hadn't even gotten to that part, but f of c equals 2/3 on our interval from -4 to 1. Alright, so you're checking if it's continuous. Make sure you always give a reason, even if it's continuous or not continuous. If that passes, you move on to the next step, which is where you plug in your x values to get the y values to see if it's between those y values. That works. It works, but if that doesn't work, it's not applicable. Okay, so let's look at C. So we have another rational function. So when you see these rational functions, you just need to be thinking vertical asymptote. So we have a vertical asymptote at x equals 2 this time. So we're on the interval from -1 to 1. Well, is 2 in between -1 and 1? No, it's not. So we can say f of x is continuous on the interval from -1 to 1. And we can say f of x is only discontinuous at x equals 2. We could put parentheses vertical asymptote, which isn't in the interval. So you just have to mention that vertical asymptote and just show that it's not in the interval. So step 1 works here. Alright, so for step 2, remember we have to get the y value. So we're going to plug in f of -1. So that'll give us positive 1/3. And then we have to do f of 1. Which will give us -1. So we need to see if our y value, -1/2 here, is that between -1 and 1/3. Yes, it is. So we got to write it out. F of c equals -1/2 is between f of -1 and f of 1. Okay, because -1/2 is between these two numbers, so you're just writing out the statement that it's between these two. So check. So now we can say, therefore, the IVT is applicable for f of c equals -1/2 on our interval from -1 to 1. Okay, now it did say in the directions, if it is applicable, we have to find the value of c. So what you're going to do to find the value of c, and on your homework, you will be able to use your calculator, so just keep that in mind because you will need it on the homework, but we should be able to do these without the calculator. What you're going to do to get the c, you're going to take whatever your f of x is. So see how it's x over x minus 2? You're just going to replace those x's with c's. So that's really going to be c over c minus 2. Equal to whatever the f of c or the y value is, which is -1/2. So you just take your equation and replace it with c's and set it equal to the y value. And then you just solve however you would solve algebraically. I'm going to cross multiply. So this would be 2c equals negative times c minus 2. So 2c equals negative c plus 2. Or 3c equals 2. So c would just be equal to 2/3. The only thing you have to check for, make sure this c value is between your intervals. So is 2/3 between -1 and 1? It is. So that c value works. Some answers you'll get 2 answers, and only 1 answer will be between the intervals. So just check, especially when you have to use your calculator on the homework assignment problems. Alright, so last problem. So this time we have an exponential function. So if you remember from exponential functions, they are always continuous, okay? So we're going to say f of x is continuous, and it doesn't matter what the interval is, but it's continuous on our interval from 3 to 5. And we can just say because exponentials are continuous. Okay, you just got to give you a reason. Make sure you state why. Okay, so then for step 2, we're going to check those y values. So we're going to plug in f of 3. And there is this minus 2 here. That sneaks up on you. So let's go down here. So anything to the 0th power is 1. So it's really negative. Hold on here. We have 1/2 to the 0th power. Yeah, which will be 1. Yeah, but we have this negative 1. So you're going to end up with negative 3 there. And then if we do f of 5, negative 1/2 to the negative 2nd power minus 2. A negative power means that you could just flip this around, get rid of the negative. So we really have negative 4 minus 2, which will give us negative 6. Okay, so we have negative 3 and negative 6. So we're trying to see, okay, is negative 4 between negative 6 and negative 3? Yes, it is. So we can say f of c equals negative 4 is between f of 3 and f of 5. So that works. So now we can say, therefore, the IVT is applicable for f of c equals negative 4 on our interval from 3 to 5. Okay, so this does mean we're going to have to figure out what this is going to give us. Okay, so we do need to figure out what c is going to be. So what you're going to do is you're going to take your equation. Everywhere there's an x, you're going to put a c. And you're going to set it equal to whatever the y value is we're supposed to get to work. Okay, so to solve this, we're going to add this negative 2 over. That'll give us negative 2. Then I'm going to divide both sides by negative to get rid of that negative. There's a couple ways to do this. You could use logs, but since I already have this close to the same base, I can change this to a base of 2 as long as I take out a negative up here. And this already has a base of 2, which would be an exponent of 1. So now that my same bases, I could set these exponents equal to each other. So we'll have negative c plus 3 equals 1, which will be positive c minus 3 equals 1, which will give us c equals 4. Now you just have to check. So for our problem here, for this one, the interval was from 3 to 5. Well, c is between 3 to 5, so c equals 4 is correct there. Okay. So you need to know how to do this. If you had your calculator on this problem, and you will on your homework, you can put one side in y1 and one side in y2 and find where they intersect, and you would get your answer there. So just find them intersect in the calculator. So if you had your calculator, you could definitely do that for that part. Okay, so on your homework, you will have your calculator to be able to solve these problems. So if the IVT works, you can put one side in y1, one side in y2, find your intersection. Just if you get more than one answer, which on some of them you will, just make sure that the only answer that you pick is the one that falls between your interval that was for your problem. Okay, and when you are using your calculator, you're going to want to make sure that you round to 3 decimal places. That's what they use on the AP test. So 3 decimal places if you need a decimal.